It's out there, lurking in the dark, a chasm yet unfound. Come along and experience the journey with the Cache
Okay. Hello, this is the Cache Caver. I'm happy today to share with you a little bit of what I've been doing. I can't always be out caving, unfortunately. And I'm a real nerd as far as it comes to just technology. I'm a computer programmer and been having some fun with LIDAR data. So I'm able to get the LIDAR data, get it in LAS format, and I've written a program that can take that data, convert it into a three-dimensional model of the ground, and then analyze that ground. And my goal is to use the LIDAR data to make it easier to find caves. A lot of the area where I'm at is wilderness area, really rugged, which makes ridge walking very difficult. And even when I'm flying a drone, you really have a hard time seeing below trees anyway, and so the drones are useful for checking out like cliff bands and ground that's not covered in trees, but other than that, it's not that helpful, and the amount of area that you can cover is pretty limited. So the LiDAR data I've been analyzing is from southern Idaho. I think Idaho Geological Survey has recently done all of Idaho and collected LiDAR data for all of Idaho, I think down to about a meter resolution. And so let me explain one of the analysis that I've been doing, I'm calling it localized elevation. And the idea is you take a point and you count all of the neighbors within a radius of say 30 to 60 pixels, and you count up all of the elevations that are higher than the point. And the reason for doing this is if the point lies inside of a pit, then everything's going to be higher around it. So points within a pit are going to show up the most, and then points on a slope would be kind of halfway, and points on a ridge or a peak or the tops of trees are going to be the lowest values because they'll be higher than everything. And so I've written some software that will do that, and colorized the results and then overlaid them into a KML so that I can load them into Google Earth. And this is the results of what I've got. So let me go on ahead and zoom into this middle one here. One of the problems with my software is I haven't figured out how to get rid of the trees from the software. I know it can be done, and I've seen it done, and I think that would really help make better sense of the data, but it is what it is. And so looking at this data, you can see a few things. You can see these purple lines here, and they tend to be the tops of ridges. Now the green, so the blue areas tend to be on slopes, and the green and yellow and orange are low-lying, or at least locally low-lying. So if you can see here, we've got an area that looks like a fairly large pit that has a lot of low-lying area inside it. So let me go on ahead and show you. So you can see that the ridges are highlighted this purple color, stream beds and low-lying areas are highlighted green. So flat areas are kind of interesting because they're so flat. They tend to be really multicolored. Let me see. So now as you're looking, the pits tend to pop out. Like here's one here, and here, and here, and here. Now all of this area is fairly karsty and has a lot of limestone in it, so there's a fair amount of pits, and there's pits here and here and here and here. And so so far I'm thinking this method is actually pretty useful, that causes pits to kind of jump out at you, and potentially other places like in here. This might be an interesting place to look, as it's kind of this low sunken valley, and then you can see there's other pits here. So that's what I've been working on. Hope you've enjoyed the share.